In a frequency distribution, we'll make a listing of observed data values on the left, that's the X column, and we'll put their corresponding frequencies, represented by F, on the right column. That represents the number of times the X values had occurred. Pictured below is a sample of 10 adults, and they were asked a statistics question. The question was, how many credit cards do you own? 2 of them said they own no credit cards. 3 of them said they own 1 credit card. 4 people owned 2 credit cards, and 1 person had 3 credit cards. So what we want to do is we want to list the responses that we got. The responses that we got to the question were 0, 1, 2, and 3. In a frequency distribution, we don't have to write repetitions. We'll keep track of that in the frequency column. So how many zeros do we have? I count 2. I'll cross those off so that I know that I already accounted for them. How many people had 1 credit card? There are 3 people with 1 credit card. There are 4 2s, so let's put a 4 here. And 1 high roller had 3 credit cards. And now the frequency distribution is complete. In the upper right, there's a frequency distribution for a number of children that a couple has. Some couples have no children, some had 1, some had 2, 3, 4, and so on. From this distribution, we'd like to determine how many total couples were sampled and how many children total are represented in the frequency distribution. Now, one quantity that's important here is going to be multiplying the X times the F. So we could make a third column for that, because it actually does have usefulness, especially when we calculate the weighted mean. Any couple who's in the top row had 0 children. There was 1 couple in that situation. So if we multiply 0 times 1, we get 0. Any couples in the second row, though, have 1 child. There were 3 couples with 1 child. So multiplying 1 child times 3 couples gives us 3. So hopefully it's clear here that X times F represents a number of children contributed by that row. These couples had 2 children. There are 5 couples in that situation, so 2 times 5 makes 10 children in all. And then we'll keep multiplying. Now let's find the sum of the frequencies, and also let's find the sum of XF. The sum of the frequencies is 1 plus 3 plus 5 plus 2 plus 1 plus 2 plus 1. That makes 15. And the sum of the frequencies here is going to be 3 plus 10, which is 13, 19, 23, 35, 43. The sum of XF is 43. So, how many couples in all were sampled? That would be the sum of the frequencies. How many children total are represented in this frequency distribution? That would be the sum of X times F, which was 43. And I'll bring up one more question. What is the average number of children per couple? To get this answer, we'll use the weighted average formula. The sum of xf over the sum of f. That's going to be 43 over 15, which is 2.87. Which would round to 3.